So hello and welcome everyone. In this video we'll be solving Kaggle's Titanic machine learning from the disaster problem. We'll first understand its data set, everything about it. We'll understand its features and what we need to predict. Then we'll build this model. We'll use different algorithms. We'll be using logistic regression, random forest, and also decision trees. Then we'll evaluate everything and submit everything, see which one scored best. This will be a complete flow from you will be learning how to analyze this data, how to fix broken values, and also to plot graphs and see relationships between data, and then finally to train your model at the end and evaluate the result. So let's get to the screen. Alright everyone, we are here on the Kaggle page, Titanic machine learning from the disaster project. So this is the project we're gonna be solving. We're gonna be submitting to this competition. So let's get into the data tab, and what we'll be given is we'll be given this training data and testing data. These are all the features and all. Here you can see we are gonna be given three files. Let me explain you this thing right here. I like explaining here. Let's go here. So here I am on the XLE draft page. Here we'll be seeing what this data set is about. So I just made this really beautiful diagram. Actually it's awful. So here let's just say this is the Titanic ship. People are going there. People will be going there. There will be a lot of people going here. There will be a lot of different, maybe some are aged between 19 to 25. Some will be old. There will be females, males, and everything. There will be a lot of diversity in these people. There will be a lot of diversities. There will be kids. So what we'll need to do is we will need to guess based on all these features: his age, whether he's a male, female, how old is he. All of these things we'll need to consider and guess whether this guy right here is going to survive or die in the Titanic accident, whether he's a good character, whether he will survive or not. If he is old, he's not gonna be able to survive. Basically you need to guess whether he's gonna survive or not. Now let's look at the features of the data we are gonna be getting. So here these are the features right here. First let's do one thing. We'll download all these files. No, we'll download as zip. So now these are downloaded. What we'll do now is I'll set up the environment, and I don't want to waste time right there. So then we'll go and start coding this thing. Now I set up my Jupyter notebook environment and I copied the data right here. We have this train CSV. Here you can see all the data is right here, and then we have the tests one. We need to test our predictions using this data, and then we need to submit in this format. So let me explain all this to you. Let's go right here. So what we have, first in this data we have passenger ID. You basically know this is just a basic ID, unique identifier for a person. These represent a person. These every row represents. And then we have whether that guy has survived or not. 0 means he has died, and 1 that guy will be survived. That guy will be surviving. And then we have this P class. I don't know what this P class is. Let me just look it up. Let me go here, Kaggle. Okay, so here I'm gonna be seeing, so this P class is basically the class, ticket class. Okay, first, second, third, it represents in which class was that guy. And then we have the name of the guy, and then whether he is male or female. Then we have the age. This is what this represents is, this represents as the siblings, I guess. Yes, how many siblings did he had, and parents, children, about. This is basically about the family data, how many members were with him, siblings or father, mother. And then we have the ticket number right here, ticket, then fare, price of the ticket, and then we have the cabin, embark, port of embarkation, where did we have this embarked also. So these are our features. What we'll need to do, we'll need to use these features. So let's go and create a notebook right here. Let's rename it to Titanic. So first thing first, what we'll need to do is we'll need to analyze this data. So let's just do one thing. Let's read this import pandas first as PD, and it's running. and now we'll be importing this data. Let's say train equal to pd dot read csv. What's the path? The path is this data slash train dot csv, and then we'll also read this test data. Here, this one we have train and test. Let's read this, and now let's analyze what is the shape of this. So as you can see, we have 12 features and 891 records. About the test, let's see test. We have 11. The reason we have 11 is because we don't have this. Let me show you this survivor class here, because they won't give it this to us. Otherwise, we'll know this y variable is not available in the testing. So you know that. Let's just do train dot head to analyze this. Here you can see this is the same passenger id survived p class. If I do test dot head, and the survived class, the survived column is not here. Now what we'll do is we'll get more info about the train thing. Here we can see in the age there are a lot of values that are null. We need to have those, and in the cabin we have basically a lot of values are null, they're empty. So this column right here is, this feature right here is useless. And then we have this embarked, there are only two missing things, two missing values. Let me show you how many are there missing. And dot, I think is null, this is the one. If you run this, then you'll know 177, there are 177 rows in the dataset where this age is null, and there are a lot of rows where cabin is null and 2 only. Let me just show you this. If I go here, look here, there are a lot of columns empty. So what we have noticed is that we need to fix these three things. First, what we'll do is we'll create two variables and then we'll fix the data. Let's create x equal to train dot. We'll remove the survived. What was the column name? Survived. I guess this is the one. X is equal to 1, then dot copy, and then we'll do this for the y. Train dot, no, we'll keep the survived here. So what we have done, we have created two variables here. Features will be in this variable, and then the what we need to predict, this is in the y variable. So let's also do this for the test data, so that our normal variables, we don't change these, we only modify these ones. X test equal to test dot copy. And now if you look at these variables, x dot shape, now we have 11 here. Now if you do x dot head, and you can see that survival has been removed. So now what we'll do is we'll plot some graphs using matplotlib and see the relations. Let's write here plot graphs. Let's see, I want to see the data distribution of age. What I'll do is I'll say x age dot histogram, and then I'll say bins equal to, let's say 20, and then I'll set label. What we'll do is we'll set the label x label equal to, what is it, age, and then we'll set y label number of passengers, and then we'll show it. I'm sorry, I need to import this first, but it's still running. First, let's just import it. Import matplotlib dot plot from as, run this and run this. As you can see here, there are a lot less, there are children a little bit aged from here available in the ship. Then it goes down. A lot of people are from, you can say, 18 years to around 35 years, and then it goes down, and we have some people 60, even 70. Now let's say I want to see the distribution of male female in this. So what I need to do, I need to write this, and then value counts, then say plot, and we'll be using this as bar chart, bar graph, and then we'll set the labels, uh, X label, and then we'll be setting Y label as and then we'll show this. Let's see the, and you can see there are a lot of males right here, and then what is, oh, this was a wrong spelling, it doesn't matter. Females are less available there and males are a lot in the ship. Now let's say I want to see which among the males and females which survive the more. So what I'll need to do is I'll need to say X, let me close this and say, let me write this with, first I'll need to group this, X dot group by sex and then with survived, and then mean of this, then we need to say plot kind equal to bar, and we'll need to set, let's set the Y label and say rate, and let's just plot this, plot dot show, what is this saying? Okay, I'm sorry, I did it wrong, I had to do this it right, I needed to do it like this. This was a little bit error. Column not found, survived, what is the spelling, man? Oh, okay, I'm sorry, I need to do this on, I think, train. We don't have survived here, and you can see here that females survived more than males, and that's a little bit interesting. And even in the Titanic movie, the man hero didn't survive. So what can we say about here? So we can say that females survived a lot, I guess males helped them. So let's focus on here. So as you can see, you can use these graphs and see a lot of relationships between them. First we analyze this and then we fix the broken things, we fix the missing values. Now what we'll do is we'll need to do feature engineering. What I'll tell you, we'll need to configure these features. Let me open this thing. So as you can see here, let me just write the title first, feature. Let me write this and see here, this passenger ID, you know that this is of no use there. We don't need it. This is not gonna help us predict whether a guy survived or not. And then passenger class will help, name is not gonna help. What you can do is you can extract these from this Mr., their Miss, and you can extract their what do you call it there. I'll show you how this is gonna be helpful. We'll do a little bit of modifications here, and then we have this, obviously this is gonna help, and age, yes, this is gonna help. And then these two things, if you look at these are showing the siblings and other parent relationship. So what we'll do is we'll combine these two things and we'll create a new feature called family size, which will tell us whether and what's the family size of this guy. You will see that the more bigger the family is, his survival chance goes up. Maybe we don't know that, maybe they are helping each other, another thing, but the more the family size is, the higher the survival chance. We'll combine these two and create a feature, family size, and is alone, to see if the guy is alone, there's less survival chance, he's gonna receive less help, but if the family is big, then there's more chance. And you can see the ticket number. You know that this is not gonna help. First we'll need to fix these empty data. I just thought we already fixed that above, but we saw here that there is a mistake. We have null values here, we need to fix those first. Let's fix these null values first. What we have, let's just say x dot is null. Let's see it again. We need to fix the age first. What we'll do is we'll say age equal to x dot age dot fill null with x age dot median, and this is gonna do it for us. And if you look at it again, if you run this again, you'll see that there are 0 null values here. We'll need to do this for, let me just copy this, we'll need to do this for x test also, x test, because we'll be testing our model. So as now this age is fixed, we need to fix this embark thing also. So what we'll do is we'll also say uh, this is the spelling equal to, let's copy this, paste this, dot fill null with paste it dot mode and 0 12. We'll do this with the test also, copy paste. But here you need to remember one thing, that the thing is we need to keep this mode right here. What I mean by that is, I mean we don't need to change this mode, because that's gonna affect this value, is gonna, we don't want this value to be different for testing. And this is changed. Now let's run this above again, and this is also fixed. Let's drop this column now. X dot drop, I guess this is it, column cabin axis equal to 1. Do this. We need to do this for the test also, and see, run this again, copy it right here, and you can see our data is fixed now. So now what we'll need to do is, this was just data fixing, pre-processing. We'll do the real feature thing now, feature engineering now. So what we'll do now is we'll drop this passenger ID also. Let's copy this, copy this name, I guess passenger, I don't think this is gonna be copied right here, copy paste, or drop this. And then if I say x dot head, now we don't have this one thing, we also need to drop this ticket thing. Let's copy this, paste ticket column, let's drop it. No, oh sorry, this is just mistake spelling. Okay, this already ran, that's why it's showing this. Let me just clear this. If I say x dot head, this is, if I say x test dot head, this is still here. Let me just do this alone because this was giving error. Now if I run this, you have this. Let me check the x dot shape. We have this x test dot shape, it's similar. Now what we'll need to do is we will create two columns. We'll create family size column from these two columns. For creating this feature, the sum of family members is this plus this. We'll need to sum these two. Let's just create it. Family size, this is gonna be equal to x, what is this column name, SIBSP plus x, this is gonna be plus 1. It's gonna be plus 1 because including this guy itself. If there is an alone guy, you don't want to think that he has 0 family size, his family size is 1. So do this for test, now we'll have this family size. Let me show you. We have the family size right here, it's 2 here because himself and this sibling, he has 1 sibling right here. Now we'll create is alone. We'll create is this guy alone or not. We can create that from here, by checking family size. We'll see family size equal to 1. We this should be in integer. If I this is gonna, we'll also do this for test also. Now if I say x dot head, now you can see this guy is not alone with 2 members, he has a sibling, this has sibling, this guy is alone, so he has this alone feature. Now we have created these 2 features. What we'll need to create, we'll need to use this column to create their title. Let me show you what I mean by that. I actually made this code, this regular expression code. What this does is, let me show you. If I show you, let me just show this to you. What you will see, this has extracted the Mr., Miss, Master, Doctor, Major. This has, by these features you can guess, I mean, what is that guy's position, so you can better guess better predict the survivability of this person. So let me just show this to you. uh, what we have, you have the title right here. Now what is remaining is we need to drop this name field. Let me copy the above code. I think we had that here. Yes, it's here. And let me also copy this. What is the field name. Now we are dropping, let me say x dot head. Now that's also dropped. We have our size like this. Now what we'll need to do is we'll need to convert these text columns, this male, female, this title, and then there's this embarked. We'll need to convert these three features into numerical data, but before that we'll be splitting this data with scikit-learn. Let me write the split data and text to numerical data. We'll need to do this first and then we'll train this model and see the results. Let me go here. Okay, so what we'll do is we'll import, we'll say inform sklearn dot model selection import train test split. And then what we'll do is we'll split this data into two things. We'll say x train comma x validation data. We'll use this to evaluate our model. And then we'll say x y train y valid equal train test split. We'll provide x y and then we'll say test size equal to 0.2. This is gonna be 20% data will go into validation and 80% will go into training data, x train and y train. And then we'll also set random state so that it gives consistent results. Let me get this below so it's visible. And then we'll also set stratify equal to y. Now let's just run this, and what we'll see is, let me just print this and see what's there. If I say x train dot shape, now we have 712 rows, and if I say x valid dot shape, we have 179 rows. We'll use this for testing. And now we'll use pandas to convert these values and these text values into numerical ones. So we'll need to convert these three features. I think we should close this. Let me make it full screen. We need to convert these three things. First we'll need to convert this column, then this has text, and then this also has got text. Sorry everyone, there was some issue with the lights, so I'm just gonna be continuing like this from now without the camera. So now, as we have already done the splitting the data, what we'll need to do is we'll need to convert these what do you call these text data into numerical values. So for that we'll use this pandas function. Let's do this for the train. X train equal to, we'll need to, this is the function, and then we'll pass x train, and then we'll pass columns. Let's just first do one thing because we're gonna be needing this. Let's create categories equal to, first what's there, we have this, we have embarked, and then we have title. We'll be using one hot encoding, and then we'll say varies, and then data type will be integer. And then if I run this, let me just show you what it looks like now. Train dot shape, no head. Now you can see all of those values are created as columns. Title miss, this is for the title, this is for the gender, and these are now encoded. Everything is now numerical. We'll also need to do this for the test and validation set. Let's do this for the validation. Validation set done, and do this also for test set. We're gonna be needing this. Let's run this, and if I say x valid dot head, and this is the same, these are encoded now. And so now our thing is done. What we'll need to do now is, our data is ready to be trained. So first we'll be using let me tell you, we'll first use logistic regression. We'll use this model first to train and see the results. So we'll say from sklearn.linear model import logistic regression, and now what we'll do is we'll say model equal to logistic regression, and we'll say 1k. This is actually max, we need to say max, and we run this. Now we'll say model.fit. We'll now train this model. This is actually, we are training this, and we'll be using x train and y train, and now it's trained. Now that this model is trained, what we'll do now is we'll evaluate this model. We'll say y predictions equal to model dot predict. We'll be using, what do you call this, validation set x. Oh, we have this error, feature names. I guess this is this error. Here you can see one thing. If I say x train, I guess I know what this error is. Shape, this is the shape of this. If I say x, here we have 26 features, but here we have only 22. The reason is that because when we did this numerical encoding, here we used xtrain, so there were more values available in one hot encoding, so the more features were created, more columns were created. But in this case there were less columns created. So what we'll need to do is we'll need to do this thing. Let me create a column. We'll need to make their columns, make the features same. We'll do this by indexing. I'll say x valid equal to, what do we call this, x valid dot reindex, and we'll say columns equal to x train dot columns, and then we'll say value equal to 0. This is fill, this is gonna be fill value, and I'm gonna be doing this for the test also, x test, so that there are same number of features. Now if you look at the shape, x valid dot shape, now we have 26 features again. So now if I run this again, we have predicted this thing. Let me delete these two columns. Now what we'll do is we'll evaluate this model. For evaluating, we'll import some things. So what we'll be importing is we'll import from sklearn.metrics, we'll import accuracy, and then we'll also import classification report. We'll use these two things for now. We can also use confusion metrics. We need to say accuracy score. Now this is done, and what we'll do is we'll see the accuracy score. What I'll say is, I'll say, let me write this print. I'm gonna be using Python app string and say accuracy, and I'm gonna write this accuracy score, and we'll need to provide it x valid and y and the predictions, and we'll round this to 2. Let me show you this first. Just a second, what's this saying? I'm sorry, this is actually gonna be y valid, and we have this. Let me just do one thing. Let me just round this to 2 numbers. So this is actually 84% accuracy. And now what we'll see is we'll see the classification report. Now what we'll do is we'll say print, just directly say, don't say print, just say classification report. What we'll pass it the same things, x valid, y predictions. I guess I'll need to do this. Let me just print it so that it will be correctly visible. Now it's visible. So what we have here, we have the precision right here, and we have the recall, we have f1 score. Now let's see the confusion matrix. Let me say print and copy this. Let me just say, let me just copy these two things and then print this. So what this is saying is it predicted 98 correctly and 52 also correctly, these two, this is the amount that it didn't predict correctly. If you don't know what confusion matrix is, then you can look it up. So this was the evaluation what we did. Now you might remember that what we used is we split our training data into two sets. Now what we'll do is we'll merge these two sets and then do this final training to submit the report here and see our results. So we'll need to train this on the whole data. If you remember, we have the whole data in our x variable. We did the splitting here from x. We'll do this for the whole data. What we'll do, we'll again, as you remember, for the x thing we had not done the numerical, what do you call this, numerical conversion. We'll need to do that first. For that I'm gonna copy this code right here. Let's just say x, I'm gonna say x final, and this is gonna be x right here. Categories is already defined, and then run it, and then I'm gonna say, if I say x final dot shape, and you have 891, otherwise x train was only 700 and something. And if I say x final dot head, you can see this is the same shape now. Now as we have done this, we'll need to ensure one thing. As you can see, there are 29 features, 29 columns now. If you look at x test dot shape, there are only 26, so we'll need to re-index this. So I'll do the same thing. Let me copy this index code, I'll paste it here, and I'll say x test final. We'll do this from the x test, we'll do the re-indexing on this, and this is the same. And now if I say x test dot shape, no, this is gonna be x final. And now if I say this, what is wrong? Oh, I'm sorry, I'm printing the wrong variable. And now we have this same. Now what we'll do is we'll train the model again. Let me just copy this. We'll do this fast as we have done this already. We'll train this model and we'll say x final, and we'll provide y because this has all the values, and we'll train this. Now what we'll do is we'll make predictions. We'll say y predictions final equal to, this is gonna be equal to model dot predict, and we'll be predicting these y. Now we'll be predicting x test final. This is what we are going to be predicting. What's the error? X input contains none. If I say x test final dot is null dot sum, what is this guy saying? Okay, so right here we have this fair null column right here. So what we'll do is we'll do one thing. We'll fill this with median value. Say fair equal to x fair dot fill null, and then we'll say x fair dot median will fill, and now it's filled. If I run this thing again, and now we have, okay, I'm sorry, I'm really sorry, I did this with the x data. I should not have done that. It should be done here. X final, x final, x final, x test final. If I run this again, there is nothing right here. Now what I'll do, I'll run this thing again, and now we have the y predictions. Let me clear this cell output. So what I'll need to do now is we need to save this. So I'll create submission equal to, this is gonna be pd dot data frame. This is gonna be a pd dot data frame. We need to make the data in this form. We'll need passenger id, and then we'll need survived. This is gonna be the same as passenger id, and then there is gonna be, what is this, survived. We'll need this survived, and then this is gonna be equal to this score we obtained. If I enter this, and then if I say submission dot head, so this is it. We are gonna save this in a CSV file. So I'll say submission dot to CSV. Let's say logistic sub dot CSV. I'll say index equal to false, and then run this. And if I go here, then we have this CSV right here, and this is our prediction. We'll submit this first, and then we'll test other models like decision tree, and then we'll see random forest also. Now here I am on the page. I'll need to click on this. I'll need to select the file. Let me go to the download, select this, and then click submit. And this is our score. Our score is 77751. And if I go to the here, see what is our ranking, jump. Our rank is pretty good. It's 336. It's really at good position. And now let's try what happens with the decision tree. Do this thing with the decision tree. Let me do that thing. Let me make this full screen. Now what we are gonna do is we're gonna import this from sklearn.tree, import decision tree classifier. And now what we'll say is model equal to, copy this really big name, and then we'll provide it some parameters. We'll say max depth equal to 5, and then we'll say min sample split equal to 10, and we're gonna set random state to 42. If you don't know what these are max and this, you can, these are the hyper parameter. This is hyper parameter tuning. You can change these values and see how your model performs. This is the basically the max depth of the node in this decision tree. We don't want to keep a lot of depth, otherwise there's gonna be overfitting. So let's now train this model dot fit. We're gonna be training it on x train comma y train. I'm sorry, this was right here, minimum samples split. And now that we have trained this, what we'll do is we'll say y prediction is equal model dot predict x valid. Now what we'll say is we'll say accuracy score y prediction. We'll say we'll need to first provide y valid, and now we have, this is the accuracy score. It's pretty worse a little bit for logistic regression, that was 84. Let's just say if I change this a little bit and then do this, then do this, now we have the score is 83. 83% is the score. Now what we'll do is we'll train this on the whole final data. Let me just copy this again, paste it here. I need to say x final, and this is gonna be y, enter. And what we are doing is we are training it on the whole data. This was just for evaluating and showing the score. And now what we are just training this. So now that we have trained this on all the data, we'll save this model now. Let me just copy the old code. I'll copy this, and then first I need to just predict. I need to predict first. Where is this code? Y predictions final. I'll just copy the whole code. I don't want to be typing it. Then also this, what do you call this? Where is this? Yes, submission.to. If I'll need say decision. If I run this now, if I run this again, now we have the file. We have the decision CSV also here. And now what we'll do is we'll first train the random forest. We'll train this using random forest, then we'll see the performance for this and random forest also. Let me just say we'll submit this file later with random forest, then we'll see the performance. First let's create this. Let's say random forest, and now what I'm gonna do is I'm gonna say from sklearn.ensemble import random forest file classifier. Now I have this code for random forest right here. This an estimator, this is specifying how many trees are they're gonna be, then same this maximum depth and sample split, and this is gonna be the feature, selecting feature for the splitting. And now I'm just gonna set this, and now what we have here is we have this score, accuracy score as 83%. Now let me just copy this again. I only trained it on extend. Now we're gonna train it on the whole data. Let me copy and paste this and say instead of extend we'll say x final, and here we'll say why we can't have this. Now if I enter this, and now what I'm gonna do is I'll just do the same thing right here, copy paste. I'm doing this fast because we have already done this. And then I'm gonna enter this, and then we'll save this into CSV. We'll say random let me just go back, forest, and now here we will be having forest dot this. Now what I'm gonna do is I'm gonna upload these two, and then we'll see the performance. So now what we'll do is we'll go here and we'll make another submission, submit file, we'll browse file, and we'll say now this time we are gonna be going with decision tree, and then we'll submit this and see the what is the score. And this time it's a little bit lower, 7.6. If you go to the leaderboard, it keeps our best score, that was the last time. This has performed less better, and now we're gonna see the random forest performance. Let's go and submit this and see its score, and its score is also same to this one. So now that was all about coding this Titanic machine learning project. I hope you enjoyed this, and that was all about the random forest algorithm. I'll see you in the next video. So thank you so much for watching.